It's just it's a formality. Now, normally when you're doing torque, if you think back, R cross F. Assume it's in your notes at this point. Torque is R cross F. In other words, we had some moment arm here times the force, and the cross product here just tells us that we're multiplying perpendicular parts. So this is the moment arm or the lever arm. Moment arm is what I tend to call it. I think Hewitt calls it the lever arm. And force is force. So the moment arm should be a vector from where the axis of rotation is to where the force is applied. So in the case of this right here, if I was looking at the lever arm for the tip of this, for the other end over there, R would be a vector from my shoulder to where that is. Except I got something that's not moving at all. So what do we choose for the axis of rotation? For something not rotating, what is the axis? Someone speculate.
0.
So this end over here?
I mean, if it's not moving, is there an axis of rotation?
No, so what do we pick? These forces are still applying torque.
Would it be the end of the rope onto the beam? Or no?
Which end?
Both ropes?
There could only be
Would
one.
there be 2? No. This
If
side.
you have 2 axes of rotation, that thing is breaking apart.
The center of the beam?
Okay, center of beam. Anyone else? Someone else speculate. Again, the only way that you can be wrong is not to answer. Or if you pick 2 different points. But we're not just leaving it with what Monica said. Come on.
Where is the axis of rotation?
Yeah, the axis of rotation.
Is it not in the middle? Like I
She already said that.
Where else would it be? Like you can't. If it was off to the side, it would be spinning like lopsided. So like it has to be in the middle. No.
No, it doesn't have to be. I was hoping to hear more than 2 voices.
This might not help at all, but is the axis of rotation an angle?
No,
Or no?
no, it's a point.
It's just a point.
So far we have the middle of the beam. All right, that's not the easiest spot, but if you want to be silent, we'll do it the harder way.
Should we try the end of the beam first? No.
You want to?
It has to be either the end or the middle.
No, it doesn't have to be.
No? 3/4?
If you want.
Which side is the easiest? Do you know?
All right, so recognize part of what I was hoping to get is that no matter where you say, is if you pick a point, that works. You can pick, if it's not rotating at all, it's just sitting there, you can pick any point that you want. Now there are some things where there's a natural point, like a door is only going to swing from the hinges, one hopes. If it's swinging from some other place, you probably have a broken door. You can pick anywhere you want. So the easiest way is to pick a point where there's a force acting. Because torque has this R right here, a vector from where the force is, from the axis to where the force is applied. So if I pick a place that's acting at the force, so if I pick the middle, then the weight doesn't exert any torque.
So like if we pick FT1,
If
That's
we pick
where-
where the left-hand string acts, it exerts no torque. If I pick the right, it exerts no torque. The reason why this is not necessarily the best spot, even though it eliminates a torque, is I still have two unknowns. All right, so let's actually do some numbers here. If we pick the middle, we'll start in the middle. I know the force is up equal to force is down. Force down is 100, so whatever the tensions are, they add up to 100. Just so I don't have to keep writing subscripts, I am going to call this A, and I'm going to call that one B. So A plus B equals 100. Force is up equal to force is down. Now I'm going to do torques. Let's set up our convention. I hat, J hat, and then K hat comes at us. This exerts a torque. R is the vector right there. The force is upwards. There's my force. There's R. We'll call it 1 and 1. What's the magnitude of R?
90 degrees.
Look for meters.
Oh,
From the center of the beam, that is 4 meters long, yeah, 4 meters long, to where this rope is, which is 1 meter from the end.
0.5.
3.
You're saying X to the first rope, right?
Yes, from here to here.
It's not
What is
point-
this distance?
Oh, the whole distance, 1.5. No?
The whole beam is 4 meters long.
Oh, 2.
2, thank you. It's 2 meters. The middle of the beam.
I know, I was looking
Hold on.
at
Oh,
the
I see.
center being 1 and then, you know what I mean?
So-
Oh, duh.
Now, if that's 2 meters and that's 1 meter, what is that distance?
1 meter.
1 meter.
1 meter, yeah, okay. So R has a magnitude of 1 meter. Is it positive or negative?
Positive.
Why?
Is it going that way?
Because remember, R goes from the axis to where the force is applied. It actually goes this way,
Good. So it's negative?
negative. So I got negative 1 meter times my force, which is A. I don't know what it actually is. So that'd be the torque from this side. Over there, well, now let's take this side. So this torque, what is R?
1 meter.
Yeah, that is
Positive.
definitely not drawn to scale.
I was
Oh,
going by,
That is horrible. That can't be 2, because otherwise it actually would not balance. I'm gonna change that to 1.5. Let's make it, so for people who tune into the video later, and they skip stuff, they'll never know. So this is now 1.5 meters. Definitely not drawn to scale. All right, so this right here, what is that distance?
1 meter.
What is the distance from the middle to this end?
2 meters.
And it's 1.5 meters from here to here, so what is
Oh,
this?
that's.
0.5.
Say it again?
0.5.
Yeah, 0.5 or 1/2. All right, so it's 0.5 meters. Is that positive or negative? I like the enthusiasm there. All right, and the force is up, which is also positive, so this is 0.5 B. So what I have here is I've got my total torque. I have negative A, that, plus 0, because I do have a force acting here, right at the axis. It doesn't do anything. It's like pushing on a hinge. Minus, plus 0.5 B equals 0. All I've done is just take each individual torque and add them up. I have two equations, two unknowns. Depends on your math skills. This is why the middle is not necessarily the best place. But at least want to get those equations. So what we're going to do now is pick a different spot and come out with something that's easier to solve. For some of you, you'll look at that, you know exactly how to do it. Some of you, maybe not.
Can we redraw the beam on the second time around?
All right, so if that's 4 meters, the middle is there, so I got a rope there, and then the other rope there. That's closer to scale. That's 1 meter, that's 1.5 meters. That's 2 meters. I've got weight acting down here. I have 100 newtons acting down there. I've got B acting up, and I've got A acting up. So what I'm gonna do now is I'm gonna choose this as my axis of rotation. And I'm gonna add up my torques. So I know that the total torque equals 0. Same convention, I hat, J hat, K hat. All right, so the torque by A, well, R is 0, so it's 0 times A, which is 0, plus. All right, so now I'm here. What is R? Going from here to here.
One more time, I'm sorry.
R for the weight. What is the moment arm? Going from my axis of rotation to where this force is applied.
1 meter.
Positive 1.5 meter.
I've heard 1 meter and 1.5 meters. Which is it?
I'm guessing 1 because it's half of the 2 meter.
Yeah.
It's in the center of the.
It's 2 meters, from this end, it's 1 meter and then 2 meters. All right, so that'd be 1 times my weight, which is negative 100 because it's down, plus, now this last one, what is R for the last one?
$1.5.
It is. That's 1.5 times my force, which is B, which is up. So I wrote all that stuff out. Really, the math problem here is I have 1.5 B minus 100 equals 0. That's all this is. At 100, so this 1.5 B must be equal to 100, and then divide by 1.5, 1.5. And so B becomes, what, 66.6 repeating newtons. A should be 33 1/3. That's 66.6 repeating, this 33.3 repeating. Just because I know the sum up has to equal the sum down, unless that's wrong. Divided by 3.
That's right.
Okay. Now, in reality, if you did this lab, you'll have force sensors here, so you'll be measuring it. Odds are, it's not gonna come out like that. You've done physics labs, you know that they usually don't work out perfectly. So let's do a more realistic setup here. You have the beam, you find the mass, you have a meter stick, you find the mass. So mass of beam, 0.1147 kilograms. You'll have it strung up at 0.199 meters, and you'll have another one strung up here at 0.799 meters. This is 0 meters at this end and 1 meter at this end. We will assume that the meter stick has a uniform distribution. In other words, the weight, we can pretend that the weight is acting smack dab in the middle at 50 centimeters. Actually, no, strike that. Because you'll actually figure out where the center of mass is. Center of mass, why don't we put the center of mass at 0.501 meters? Just a little bit off of center, which is more realistic. You find that because I chose these numbers here, find this to be 0.57 newtons and 0.54 newtons. Somewhat close to each other. You now want to know what is the total torque. Now, it should be 0. Reality probably won't be if this is an experiment. In order to find the torque though, I know it's supposed to be 0, but it's not, there's no obvious axis here, so we get to pick any axis we want. Because right now, all of my measurements are based upon 0 being down there. Why don't we pick this end over here to be the axis? So that's my axis right there, because I already have all my R's. I have a weight acting down, W equals G, 0.1147, 1147 kilograms, times, since we're pretending to be a lab, 9.798 meters per second squared. And what do we get as the weight of the meter stick?
1.123.
1.123
8. Trying to round to 4.
units.
Kilogram meters per second. Newtons.
Or kilogram meters per second squared. Well, first off, the sum of the forces up should equal the sum of the forces down. So if I add those two together, I have 0.57 newtons plus 0.54 newtons minus 1.1238 newtons. And what do I get as the total force, experimentally?
Negative 0.0138.
Negative 0.0138.
Why are you subtracting that total?
I added the 3 forces. I
Okay.
have 2 of them that are up,
Uh-huh.
1 that is down. The
Oh,
one that's
okay.
down I'm making negative.
Okay. Because before we had 100 newtons down,
Yep.
we multiplied 10 by the weight. And we
Yeah,
got
I
100 newtons.
put it on Earth too, so G was 10 meters per second squared.
Okay.
I'm making this more realistic.
Okay.
Now, the sum should be 0, the sum is not. Again, physics lab. It happens. Next up, let's look at the torques. I'm going to choose the left end as the position, so I'm going to add up my torques. Now, all of my moment arms are running horizontally. My forces are running vertically. They are perpendicular to each other. If if R is perpendicular to the force, then the magnitude of the torque is just RF. So my torques, my R 0.199 times 0.57 newtons plus 0.501 meters times negative 1.1238 plus the last R from what axis to where the force is applied, 0.799 meters, 0.54 newtons. Now realistically, I don't expect it to be 0, but I do expect it to be somewhat close. And again.
Got negative, point 0.18133
Apparently, I wanted to make more marks than I wanted. So, negative 0.0,
181338.
1328.
38. 1338. That's, yeah.
Units?